Okay, so this by del x ay, by del x ay, by del x ay, it is already been cancelled out. In the similar way, when we compare for the y cap and z cap, what we get, the LHS is equal to RHS, right? So this is the proof of the second identity of this gradient product rule. Okay, now let's come to the divergence, the product rule associated with the divergence, right? Product rule. Okay, for divergence, act on a vector. So how do we get a vector? By is multiplying the scalar with a vector, and again we can another way we can get is the cross product of the cross product of two vectors. So first of all, we'll look at this. So this is a vector, this is a vector, either this vector will act on this, so we'll get the first product rule, and when this vector will act on this, we'll get the second rule, right? So what okay, so but it actually equal to actually this a is not a constant, so instead of a it is better to write it as a f. F is some f is of course a variable, but it is a scalar quantity. So what is it is gonna equal to the del of f now dot a. Of course this answer is gonna be a scalar quantity, and this is a scalar, plus a, and not a, it should be okay, it should be f del dot a, right? So we have to prove this. So we know that the del dot f of a, so here we have proof. So what we can write is del x cap plus del y cap plus del z cap dot product with f of ax x cap plus f of ay y cap plus f of az z cap. Now this is a dot product, so answer will be del x f of ax, right, plus del of y f of ay plus del of z f of az. Okay, so we can write like this. This is nothing, these two are the scalar quantity, and this is nothing that what I am going to do is using the product rule for the differentiation again. So it is like this, plus in the similar way we will have f del of y a of y plus a of y del of y of f plus f del of z a of z plus a of z del of z of f, right? So we'll take the common, not the take the common, we'll rearrange the term with the coefficient f. So del x ax, and again we have these three terms, plus del of y a of y plus del of z a of z, right? And then we'll rearrange the term with the coefficient a ax ay and az, right? So will ax del of x of f, ay del of f del of y of f, and then a of z del of z of f, yeah. And we can write like this, right? A of x cap plus a of y cap plus a of z z cap, yes. And for this term we will have this a of x cap plus a of y cap plus a of z cap, right? And then we have this del x cap plus del y cap plus del z cap, and f will be out here. So this is actually the del operator, and this is the vector, right? And what is this? This is the a vector dot, this is the del f. Okay, yeah. So this is it. So this is the first product rule for the divergence. Similarly, we will write the second proof of divergence and we'll try to prove it. Okay.